So today we're going to talk about solving combined inequalities. You may say, wait a minute, didn't we do that like graphing systems of linear inequalities? It's kind of a little bit simpler than that. It's actually, we're going to be graphing these. You're right, we're going to graph more than one. But we're going to be graphing these on a number line, not on a coordinate plane. Okay? So it's going to be a little bit simpler. Instead of two variables, guess how many variables you're going to have then?
4.
What? On a number line?
Oh, what?
Just one, okay. What are you talking about? Okay, so for graphing things on a coordinate plane, you need two variables, right? X, Y. For this one, you're just going to have one variable, okay, on a number line. So you guys remember, let me hide the answer. You guys remember how to graph? A little review. Remember graphing inequalities with one variable? Something like this. X less than -2. Do you guys remember how to graph this on a number line? Well, somebody give me some numbers that is true for this. Some solutions. What are numbers that are less than 2? Could be 2. -100, yeah. Oh, I'm sorry. Greater than -2. I was kidding. Sorry, my bad. Greater than -2, yes. -1, sure. 0, does 0 work?
Yes.
How many solutions are there for this? Infinitely many. Andrew, how would you describe this on a graph? How would you represent this on a number line?
It would be a vertical line.
Oh, we're not graphing on a x and y axis. We're just graphing on a number line. So this is simpler. Yeah, so it'll be just. Hold on. Andrew?
Put a arrow that was at -2 and then pointing the way with the greater numbers.
Exactly.
So like
Yeah, there you go. Right here. So graph these with -3 to 3 and then I did that. And then open circle at -2 because is -2 part of my solution? No, it's not. So we graph that. Okay. On the same kind of setting, everybody go ahead and draw the same number line like this. What about how would you graph this? X less than -3. This is simple. Now it says x is less than or equal to 3. So go ahead, everybody try. I'll give you time. Should be pretty straightforward. Harrison, how would you graph this?
Would you keep the shaded on 3?
Yes? To the left or right? To the left. Because we want all the numbers that are less than 3, including 3 because it says x is less than or equal to 3. Now, these are some reviews, but now we're going to be then combining these. So look at C. What would the graph on a number line be for x is greater than -2 and x is less than or equal to 3? And so I have this word and in the middle. And means, anybody have any guess as to which solution we want when I say, because look, solution for the first one is all these numbers, right? And then solution for the second inequality is all these numbers. What do we mean by and? Anybody have an idea? Judy? Yeah, we want solution for both of these at the same time, right? So which numbers then? You would do a little scratch work. This is the scratch work that you would do. So you would do something like this. You would draw, okay, we graph both of these together on a same number line, just like how we graph the systems of linear inequalities in the same x and y axis, right? So we would graph them on the same number line, and we will look at if I'm looking for a solution for both of these. What do you think the solution of both of these lie on? Yes.
where the two arrow in both lines are on the number line.
Sure. Where they both overlap, right? Where they overlap, right? Very good. So it'll look something like, there's my final answer. So you see my scratch work up here? Don't give me the scratch work. Do something on your homework to indicate which one is your final answer. So for this one, I circled it, okay? I have a scratch work up here. I have circled my answer. And so when we say and, we want to know where they overlap, in other words, right? Because that's where, right, those numbers are solution for both of these inequalities, okay? Right? Does that make sense? All right. Any questions? Okay, let's move on then. So I want to talk a little bit more about this graph. On your homework tonight, they're going to ask you to write this as a sentence, not as a graph. Does anybody know how to describe these points as a sentence? Yes. All real numbers.
All real numbers in between, like, wait, no.
Yeah, you're right. All real numbers is between, yeah.
All real numbers are between -2 and 3, including 3.
Yes, very good.
Oh.
So all real numbers between -2 and 3, and you need to include 3. Okay? It's because you have the closed circle, right? At 3, which means we have to include 3. If you just say this, what would this mean? All real numbers between -2 and 3. Yeah.
That means both of them are open circle.
Yeah, both of them are open circle. That means the last two numbers are not included in the set, right? So if you want to include something, if you're not going to include anything, that's okay. You don't have to say anything. But if you want to include the endpoints, you have to say including 3 like this. Yes, sir? Question?
Can't you write that sentence like -2 is less than x is less than 3? Or x is less than 3 like that?
Right. So another way of saying it is x is greater than -2 and x is less than 3. Using this word and in the middle. You're right. So we'll talk about that in a minute. You're right. So did you hear what Kobe said? Kobe said, well, isn't that same as just reading whatever it says right here? All real numbers, what? Greater than 2 and less than or equal to 3. It's the same thing. Very good. But normally for these kind of graph, we write it this way. It's a little bit simpler. But yeah, you're totally right. That's correct. Okay. Turns out though, whenever you get this sort of graph where you have something in between two numbers, right? There's another way of writing these inequalities. They use this shortcut. Have you guys ever seen this before? Yeah, you have x in the middle, and then you have a smaller number on the left,
Oh, we did that.
bigger number on the right. Yeah, some of you have made, and then you have less than sign, right? Inequalities for both of these. You cannot have one of them greater than. That'd be wrong. Or you cannot have both of them greater than. You see how I have less than over here?
But wasn't that like the draw by line project?
Yeah, it's very good. You guys remember this from Draw by Line project? We did this. Remember? So if you want to know number between two numbers, this is one. So actually, this is a shortcut of writing these two inequalities, combined inequalities. Okay. And let me show you why this is a shortcut. Question?
Wait, are they always going to be less than?
Yeah. You would. If you're gonna use this notation, you have to have less than symbol here. If you didn't, then it won't make sense. And this is the normal way of writing. This is the general way of writing. If you have greater than, you would have to either rewrite it or something, or you cannot have one of them less than, the other greater than, and it will not give you this graph if you have that. Okay. So let me show you why this x greater than -2 and x less than or equal to 3 becomes this. How they got that as a shortcut. Okay, you ready? So what they did was by the way, whenever we write these inequalities, we would like to write the x's first, right? And we read with the x's first. It just makes more sense. But could I rewrite it this way? Is that okay? -2 less than x. Is that same as x greater than -2? Yeah, I just read it. But by the way, the way you read this, you should read x first. Because when you say -2 is less than x, it's kind of hard to see what value of x's are, right? That makes it true. But if you read it as x greater than -2, it makes more sense, doesn't it? So even if it's written this way, you should read with x first. That's why it's a good idea to write x first. But here I did it this way because notice I have less than symbol for both of these inequalities, right? And you have and in the middle. If you have this, you could kind of squeeze them together and kind of, since x is being in the middle in the shared, they're sharing both same x, you could squeeze them together and write this shortcut. That's where they get the shortcut from, okay? But they all mean the same. You could either write x greater than -2 and x less than 3, or x is between -2 and 3, including 3. Do you see where they get that shortcut from? And this is the only shortcut you have for these inequalities. There are no other shortcuts other than this case, okay? You have to have both of them. You have to have this graph, first of all. You have to have a bunch of numbers between two numbers. Then you could rewrite it this way because it represents this inequality. Okay? These combined inequalities. Later today, when we're doing some examples, you have to go back. So they give you this shortcut. Do you think you could go back to these two inequalities using and in the middle?
Yeah.
Yeah, it's simple. You just look at the left side, because that's one of the inequalities you get. You just basically hide one of them. You see how you hide this one? You get that one, and what else do you get? Another one is then you get this, right? x less than 3. You see what I mean? Those are the two inequalities you get. Anyway, okay, so may I move on then? So what if you have there? So this is our first combined inequality. Not only can you have n, you could have some other word in the middle. Does anybody know which word we use other than n? Yeah, or is correct. So you could have this: x greater than -2 or x less than 3. And it's exactly the same as before. Now instead of and we have or. Let's see how that changes the graph. Okay, it will change. And so let me show you how this works. Or okay. So the word or means other than and. Anybody want to guess what or means here? And means we want where it has to be a solution for both of them, right? We want the number. We want a number such that it's solution for both of these inequalities. When you have or, it means a little bit different. Anybody know what or means? Anyone want to guess? Yeah.
Oh, like. Oh wait. I know how to the number line. Like, won't the number line look like there's like two arrows pointing like opposite directions? Like,
Oh, they don't always look like that. Yeah, some of them will look like that, like sometimes, but not always. It depends on what kind of inequalities you have. So or means, you know how and means we're looking for a number that is solution for both of them. Or means it has to be solution for at least one of them. Okay. So it doesn't have to be solution for both of them. We just want solution for at least one. So or means it's a solution for at least one of the inequality. Does that make sense? We'll do an example. Let's graph these. Okay, so let's graph them. Here's my scratch work, right? As before, we have the same sort of scratch work. X greater than -2, x is less than 3. Now let me ask you this: is 0 a solution for at least one of the inequality? Which one? X is less than 3, isn't that right? Isn't right? Also, or x is greater than -2. Well, 0 happens to be a solution for both of them. That's great. Okay, so we could include that. It turns out everything in between these we could include, right? They're a solution for both. What about -3? Is -3 solution for at least one of these inequality? Yes, it is. What is this solution of? X less than 3. Is this solution for the first one, x greater than -2? -3? No. But it is a solution for x less than 3. So could we include that number as our solution? Yes, because it says or means it has to be a solution for at least one of the inequality. That's fine. What about 4? Is 4 a solution for at least one of the inequality? Yes, it is. Which one? X is greater than -2. It is not solution for x less than 3, but it is solution for x greater than -2. That's perfect. Now, what about -2? Could we include -2 as our solution? How many people say yes? Raise your hand. How many people say no? There's an open circle there. You are correct. We can include it. What is the -2 solution of? Andrew.
X less than 3.
That's right. It is solution for x less than 3. As you can see, the arrow from 3, it passes -2, doesn't it? So it is a solution. Is it a solution for x greater than -2? No, but it doesn't matter, right? It is a solution for the other one, so we include that number. That's part of our solution, right? What about 3, Matthew? Would 3 be our solution?
Yeah.
Why? You're right. So it has to be a solution for at least one of the inequality, right? Which one is the solution for? 3. Yeah, x greater than -2. Doesn't that include it? Even though it's not solution for x less than 3, it is solution for x greater than 2. Right? So then how do we graph this? Derek, you have an idea?
wait, no, would it be all the numbers?
You're right. It is all real numbers. And how do you graph all real numbers? You graph this one. Okay, so this one, the solution is all real numbers. Okay? Does that make sense? Because or means it has to be a solution for at least one of the inequalities that they gave you. In this case, it's all real numbers. You understand? Okay. Another way of thinking about or, some people say it this way. We include both of the solutions together. Okay, that's another way to think about it. It means the same, right? You could either say it has to be a solution for at least one of them, or that means you include solutions for both of them all together. Anyway, whichever way you like to think of it. Yeah, Caroline, question? Circles. So the one on top is your scratch work. For this one, in order to represent all real numbers, you don't put any circles there, because if you put an open circle, that means you don't include that point, which would be wrong. Does that make sense? Did you guys hear what I just said? Could I put a circle around 3 and -2, open circle? No, you don't need to. Do I need to put a closed circle for those? No, because when I do this line like this, it's including those points. You don't need to say it again. Yes?
So a line like that, like solid line to the bottom one, but above all the so it's pretty much like putting a closed circle on like every one.
Exactly. It's putting a closed circle on every single possible numbers on a number line, which is there's infinitely many of them. You can't really. That's why we highlight it this way. Very good. Okay. Very good. Any other question? So do you think if I have or, it'll always look like all real numbers? No. It depends on the situation, right? It depends on what kind of inequalities you get. What about if you have and? Do you always get this? Do you always get a graph that looks like this on a number line? No, you don't. It depends on what you have. So let's do some examples. Are you ready? Any question? Okay, all right, let's do some examples. So let's graph this combined inequality, x less than -2 or x greater than 3. How would you graph this on a number line? Do you think you need to do some scratch work and try to figure out which one is which and so forth? Go ahead, everybody try. It turns out sometimes you don't even need the scratch work. But anyway, sometimes you do, sometimes you won't. But this time I don't think you will. We'll see. Go ahead, everybody try. I'll give you time. All right, so some of you are kind of confused. So first of all, you got the graph, right? Could you do the little scratch work here? You're going to get two inequalities, right? And so let's graph them. There. Don't you get x less than 2, x greater than 3? Or means what?
It could be either one.
Yeah, it could be either one. So that's it. You're done. We include the solution of this plus the other one.
What do you write?
That's what you write.
There's no sentence.
Oh, I didn't ask for the sentence. If I did, can somebody give me a sentence for this? Because on the book, on your homework, it asks you both, I think. Yeah.
All real numbers less than -2.
Yeah. All real numbers less than -2. What word should we use? Or and? Or. Right? We need or, right? Or means, right? It could be either one of these, right? So, all real numbers less than -2 or greater than 3 is how you write. So this time, you don't really need to do any scratch work, right? Because it's kind of obvious. You include both of them, you're done. Any question? Does that make sense? You get this or no? Okay, talk to each other. Go ahead, see if it makes sense. Ask each other questions. How about if I give you this? Now, it's the same exact inequalities. Instead of or, guess what I have? And. Go ahead, everybody try this. I'll give you time. Remember what and means, okay? And means what, guys? Yeah, it's got to be solution for both of them, right? We're looking for solution. In other words, we're looking for places where they overlap, right? Good, everybody try. So, for example 2, I don't really need to do scratch work because I just did one up here, didn't I? They have the same thing. Now, look at, pretend this is my scratch work then. Do you see anywhere they overlap? In other words, is there any number that is going to be solution for this inequality, x less than -2, and at the same time greater than 3? No. Guess what our solution is, Elizabeth?
No.
Oh, you think it's everything between? Well, do you see any where they overlap? Is there any place where they overlap? Because overlapping part is the solution. Is there any overlapping part? No. So that would not be your solution, Maddie. Yeah, this has no solution. Yeah, there's no overlap. That's it. How do you represent no solution? Just blank number line. Okay, you don't put anything on the number line, so no solution. This one, right? There is no such number that is going to be true for first inequality and the second inequality. Is there? Right? Is 0 a solution for any one of these? No, it's not. It's not. Okay. Well, it's got to be solution for both of them. Of course, it's not. It's not even solution for any one of them. So. Okay, do you understand? Yes? Try this one now. X greater than -2 or x greater than 3. Now we have or in the middle. Let's see what kind of numbers we get as our solution. Go ahead, everybody graph. So, did you all do a little scratch work?
Yeah.
Okay, I did right here. There's Can I leave it like this for my answer? No. Okay. Now, when we say or, again, it means solution for either one of these is fine, right? So, anybody know then how to graph? How about who haven't I called today? I haven't called. Yes. How about Shirak? What do you think?
Okay, for the sentence.
Okay, you could well, actually graph. Well, yeah, do a sentence first, because that's the same as graph.
Right, but I put all real numbers greater than -2 or greater than 3.
Okay, how many people agree with all real numbers greater than -2 or greater than -3? Greater than 3. That's not really simplified. So what does that mean when you do that? This is what, whatever you said, that's what it describes this graph. So Taline, what do you think?
Is all real numbers greater than -2?
Correct. That's what you get, right? Because you want a solution, right? That's going to be either one of these, but this one, x greater than -2, right? Really says, it includes the other one too, so you don't need to say it again. So it's all real numbers greater than -2 is the final solution. Yeah, you don't need to say greater than 3 because it's included in here. Any question? How many people got this right? Raise your hand. Good. Good. Now let's move on. Okay, what about this? I have the same exact one as before. Now I have and. X greater than -2 and x greater than 3. How would that change? Before we had or there, now we have and. How would that be different? Go ahead, everybody try now. Kyle, what would this look like? First of all, did you do the scratch work right here?
Yeah.
So the same as before. So then what would then our final answer be?
All real numbers greater than 3.
Correct. How many people agree? Okay. Because that's where they overlap, right? Right. All numbers greater than 3 is where it's going to be solution for both of these to be true, right? That's where they overlap right here. Does that make sense? Some of you did this. I saw this and I thought that was interesting. Some of you did this, like this. Okay, and you say, oh, there's no overlapping. What do I do? Can I do this? What's wrong with this? Yeah, you have to what? You have to do what, Andrew?
You have to make the line go longer.
Yeah, yeah. Just speak. Yeah, you have to go like this, and that you can see that's where the overlap happens, right? So don't draw it too short. Okay, may I move on? Are we good?
Yeah.
All right. So, example 5 says graph -3 less than x minus 2 less than 4, and you say, wait a minute. This will be great if I have what in the middle by itself? X. This time it doesn't. So, because if I just had x in the middle, I know which it'll be between -3 and 4, something like that, right? But that's not what we have. X minus 2. So who remembers what this was a shortcut of? Emily?
Wait, no, I don't know.
Oh, this was a shortcut of? How many inequalities does this represent? 2. What are those 2 inequalities? Who remembers? Okay, remember I told you easiest way is what? Hide this part. Is one of them is this, right? The other one is what? The other one is this, right? Those are the 2 inequalities it's really representing. What word goes in the middle?
And.
Yeah, and. You guys remember? So don't you just get this? Right? You have the one on the left, this part, and you have the one on the right, that part. And guess what we have to do then? Solve for x and graph, right? Go ahead, everybody try. Remember I told you you have to kind of go backwards. From the shortcut, you have to be able to write these 2 inequalities, right, separately. Okay, this is how you do that. Okay, go ahead, everybody try. Tell me what you get. So, when you solve for x, first of all, for the one on the left, okay, one on the left, what are you going to do to solve for x? Of course, you're going to, first of all, is this the best way to write, or should I have the x on the left side? Yeah? X on the left side. How do you read this, by the way? Should I read -3 less than or equal to x minus 2? No, you should read with x, wherever the variable is first. So, x minus 2 is greater than or equal to -3. Then you're going to add 2. Don't you get x is greater than or equal to -1? Yes? For the other one, you're going to add 2. You get x is less than 6. And you have and in the middle. Do you think we need to do some scratch work here? Did you do this? So you get x greater than or equal to -1, including -1 there, and x less than 6. By the way, somebody asked, how do I know that this was and in the middle? Because that's really important, right? What if this was or? How do I know that there's and in the middle? Yes, Kobe?
Oh, because like the short, isn't and like the only way to get that shortcut?
That's right. When you have this shortcut, you could only have and in the middle. Okay, you cannot never have or there. Okay, so what would then this look like when you graph? Finally, your answer should be, how about John? And means we want the solution where they overlap, right, John? So what would it look like? All your numbers between? Including 6 or including -1? That's correct. Not 6, right, guys? Does that make sense? Any question? How many people got this graph? Raise your hand. Easy? Very good. Now, did anybody recognize this and go, wait a minute, what if I rewrite this with -1 and see if I could squeeze them in together? Would that work too? I rewrote, it still works, same thing, right? Of course, it's representing same inequalities, right? Does that make sense? You could, but you could just stop here. You get the right answer. It's fine. It's just if you wanted to see how this thing works, right? Where every time you get this graph, right, you can always squeeze them in together after you rearrange them, put in the correct order. Does this make sense? Any question? All right. Okay, here's some facts you need to know, guys. Instead of calling these combined inequalities with and in the middle or combined inequality with or in the middle, you see how it's kind of long? So we come up with names. So combined inequality with and in the middle are called the, anybody have any idea? No? That's okay, I'll tell you. It's called conjunction. It's called a conjunction. So the inequalities with and is called a conjunction. Oh. And the inequalities with or is called a disjunction. So just on your homework tonight, okay, it's going to refer to these inequalities as either conjunction or disjunction. So when you see conjunction, which word should you know? Yeah, it goes with and. If you see disjunction, which word should you know? Or. Very good. So here's an example. Is this combined inequality conjunction or disjunction? It's a disjunction, right? Go ahead and then how would you do? Solve for D for both of them and then graph. Go ahead, everybody try. I'll give you time. And if you're not done writing the fact, I'll give you time also. So go ahead, everybody try. Okay, this is a good question. Class, how many inequalities you see in this example 6? 2. Are there 4? No, okay, you don't. Is this one on the left a shortcut? No, it's not, is it? This is just one inequality. It's just these are kind of in both left and right. Does that make sense? So don't think that there are 4. There's only 2 inequalities, right? There are only 2 inequalities. You just have to solve for these. So what are you going to do to the first one? How would you gather the D? Oops.
Solve for D.
Yeah, solve for D. How would you do that, Kobe?
Add 2D to both sides.
Yeah, you could add 2D to both sides. I added D. Is that okay if I did? Okay, it's fine. I did that on purpose, kind of. Because when you do this, I get 5 less than 3 minus D, right? And then I add subtract 3. When I divide by -1, what do you have to do, guys? You must reverse the inequality symbol. I did this on purpose because sometimes you cannot avoid. This time, if you add both sides by 2D, yes, you could avoid not reversing it. But sometimes you can't. So I just want you to remind you guys that you have to do that. And then the other one, do the same. You should have all gotten D less than or equal to -2 or D less than 2. How many people are up to here so far? Anybody need, okay, some people need more time. Okay, I'll give you more time. Go ahead. When you graph, don't you get, here's my scratch work. D less than or equal to -2. D less than 2. Now, we want or, so what's that mean? It's got to be a solution for either one of these. It's fine, right? So, did you all get all real numbers less than 2? Any question? Is this pretty straightforward? Okay, good.